All right, so today we're going to be talking about something called binomial probability. I'm actually super bummed because this is one of my favorite lessons that I have for in all of my classes. Um, so anyway, what we're going to be dealing with today are experiments that only have two outcomes. Okay, that's where we get the word binomial from. Okay, so winning or losing, heads or tails, boy or girl. Okay, these experiments are called binomial experiments, provided that each trial is independent of all the other ones. Each trial has only two possible outcomes, and the probability of success is the same for each trial. So, like if you just have two marbles in a hat, like red and blue, and you pull one out and then you pull the other one out, okay, that's not a binomial experiment because the probability of success was different. It would be a binomial experiment if you put the marble back in after each time, but not if you keep it out. Okay, so the probability has to remain the same for each trial. So to start off with, let's think of an experiment. Okay, suppose you are shooting 3 free throws and must make 2 of them. Well, how can we do that? Okay, we know that this is a binomial experiment because each trial is independent of each other. Okay, each free throw, it doesn't matter the outcome of the previous free throw. All right. You only have two possible outcomes. You're either going to make it or you're going to miss it. And then the probability of success is going to be the same for each trial, assuming that you're like a 60% free throw shooter. That probability of success is going to stay the same regardless. Okay, we're talking, I mean, it can get way more complicated than that, but for all we're talking about right now, that would be a binomial experiment. Okay, now how can you make those two? Well, you could make the first one, you can make the second one, and you can miss the third one. All right, so S is a success, in this case a make, and an F is a failure, okay, which in this case would be a miss. So you could make the first two and miss the last one. You could make the first one, miss the second one, and make the last one, okay? Or you could miss the first one and then make the next two. Those are the only three ways that you could make 2 out of the 3. But what you need to understand is the probability of each one of these would be the exact same. Okay? Basic probability. You multiply this probability times this probability times this probability. Well, because all three of these they look the exact same. They have 2 S's and 1 F. They would have the same probability. So that's where this can get tricky because there are multiple ways that the same outcome, in this case making 2 out of 3, can occur. So when it comes to calculating binomial probability, we have to use a combination, okay? Because order doesn't matter here. It doesn't matter how you make 2 of the 3 as long as you make 2 of the 3. So we have to have a combination. Okay, that's what this part of the formula is all about. And then you have your probability of success raised to how many times you have to have success times the probability of failure raised to how many times you have to fail. Okay, and that gives us the probability of R successes in N trials. So this is the formula that we use. It's going to make a lot more sense when we actually practice it here in just a second. Okay, so let's look at a free throw example. Okay, suppose you are a 72% free throw shooter. You have a 72% chance of making a free throw. If you shoot 3 times, what is the probability that you make exactly 2 out of 3? Okay, so it doesn't matter whether you go make, miss, make, or miss, make, okay? That probability would all be the same. So to calculate the total probability of 2 out of 3, all right, we are going to have, you have 3 trials. You need to have 2 successes. So 3C2 there. Okay. The probability of success is 72%, so 0.72. Now that you need to raise that to how many successes you need, which in this case would be 2. Well, if you have 2 successes, that means you're going to have 1 failure. The probability of a failure in this case is 0.028. Obviously, these 2 probabilities have to add up to 1, since it's a binomial experiment. Only 2 things are possible. And you need 1 failure. Okay, so that's the formula. That considers make, miss, make, and miss, make. That considers the 3 different ones. Actually, this combination part is what considers the 3 different possible ways to get 2 out of the 3. Okay, so then to calculate the total probability there, you just multiply it all together. So 3C2, which by the way is 3. That's the 3 different ways you can get 2 out of 3. Okay, anyway. So 3C2 times 0.72 raised to the second power, 0.28 raised to the first power. Okay, and that gives you the probability of making 2 out of 3. All right, right there. 4, 3, 5, round to 3 decimal places. If you were to convert this to a percentage, you would have a 43.5% chance of making 2 out of 3. Okay, that's what this is saying. All right, let's look at one, a multiple choice exam. I got 3 different scenarios here, okay, but 10-question multiple choice quiz. You didn't study for it. Each question has 4 possible responses. Only one of each is correct. One of which, I should say which. One of which is correct. Find each probability. Okay, so you are just blindly guessing. You're not even reading the question really. You're just picking an answer. What is the probability of getting 6 of those 10 questions correct? Okay, well, again, probability of 6 out of 10 would be, you have 10 trials, you need to have 6 successes, times, well, what is the probability of success here? Well, if it's got 4 possibles and only one's correct, your probability of success is 0.25. Okay, you need 6 successes, and therefore you need 4 failures. Okay, probability of failure is 0.75, 3 out of 4. Obviously, you've got 4 answers, only one's correct. That means 3 are wrong, so 3 out of 4 would be your probability of failure. Okay, so if you were to multiply all of that out, all right, 10C6, 0.25 raised to the 6th power, 0.75 raised to the 4th power. It's not very good. 0.16. Move the decimal point over twice. You've got a 1.6% chance of getting 6 questions right. Okay? And it doesn't get any better the more you want. Okay? So 4 or fewer and 8 or more would be the other ones. Now, I threw these ones on here because 4 or fewer. Okay? So you actually have to add a bunch of probabilities up here. You have to get the probability of getting 0 right, plus the probability of getting 1 right, plus the probability of 2, 3, and 4. Okay? I'm not going to run through that whole formula. Hopefully the formula makes sense. You would actually just use the same basic outline. You're going to be changing the number of successes you want here, which changes the number of successes you want here, and also the number of failures. So really, each of these formulas, you can use the same basic template. You just are going to be changing this number, and this number, because the probabilities of successing and failing are going to be the same each time. But with 4 or fewer, you just have to add up all those different scenarios. Okay, same with 8 or more. Probability of 8 plus the probability of 9 plus the probability of somehow guessing all 10 questions correct. Okay, so that's what you would be doing for these types of problems here. Okay, pretty fun formula. I wish we could do it in class because there's a lot more that I would like to go along with this, but this is what we have for right now. Okay.